So now, after we have come to the end of our statistics section, and before moving on to machine learning, I just want to illustrate a couple of differences between statistical modeling and machine learning. Frankly, there are a lot of overlaps between these fields, but it is important to know some of the key differences between these so that when you work with your own data, and that is the purpose of this course, to equip you to work with your own data, you can decide whether you should be focusing on statistical modeling or machine learning, because frankly, there's nothing more in this world that screams amateurish, except for situations when you end up using machine learning when you should be using statistical modeling. So this brief overview should let you make that decision. So there are some basic differences in theoretical underpinnings of statistics and machine learning, and they should always be borne in mind when you work with your data. So statistics, they focus on formalizing the relationship between variables in the form of mathematical equations. Machine learnings, on the other hand, comprise of algorithms that can learn from data without relying on rules-based programming or any formalization. And in statistics, formalization of relationships can include things like generating confidence intervals, etc. And obviously, these are not the things that you'll get in machine learning, and that's something you will see for yourself in the subsequent sections. Statistics is a subfield of mathematics which deals with finding relationship between variables to predict an outcome. On the other hand, machine learning, it comes from computer science and artificial intelligence, and this deals with building systems that can learn from data and instead of explicitly programmed instructions. And not only do machine learning systems learn from data, we use the same machine learning systems to actually predict unseen data. And statistics, there's a lot of emphasis on quantifying uncertainty. And in machine learning, the emphasis is almost exclusively on prediction and classification and how good your prediction or classification model is. So from a practical perspective, statistics emphasizes on formal statistical inference, things like confidence intervals, hypothesis tests in low-dimensional problems, and machine learning emphasizes on prediction and high-dimension prediction problems. One of the key things that works for me when I have to decide between statistical models and machine learning is, and that may well work for you as well, irrespective of your domain, that choice of statistical models is influenced by underlying data distribution. And that is something that we saw a lot in the previous sections, that we devoted a lot of time to checking whether our data were normally distributed or not, if the errors were normally distributed or not. But in ML models, machine learning models, the choice is based on the predictive ability of the model. So it is decoupled from data distribution, and this makes machine learning more amenable to nonlinear and other types of complex and skewed data. And for most machine learning systems, you do not need normally distributed data in any form or shape. And that is what happens in real life, that we actually very rarely do we have normally distributed data. And since we do not have normally distributed data, for me it just makes a lot of sense to work with machine learning data, with machine learning systems, and then working on identifying the algorithms which give me the best possible results, and in terms of predictive ability of the model. And in case of statistics, we get a formalized relationship between y and x in form of an equation at the end. So when we worked with linear regression, we got an equation at the end. But in machine learning, usually no equations are produced, and what we have is that we have trained a machine learning system that is going to predict on unseen data, and the upshot is how well your machine learning system predicts unseen data, but you're not going to get any equations at the end. So in case you have to report an equation or something, then machine learning is not what you should go, because for machine learning, our entire emphasis is actually to build the best possible models on a set of data and then see how good they are on another set of unseen data. And in the next lecture, I'm going to talk more about what machine learning is and different types of machine learning problems out there. And from the next section onwards, we are actually going to start with the practical examples of the different types of machine learning systems and actually start working with machine learning algorithms all across the remaining sections.